Hello, this is Ms. DB, and in this video I'm going to show you how to do some of the problems from the 8.5 Part 2 Solving Rational Inequalities section. So in this section we're going to be looking at graphs and algebraic solutions to inequalities, so with less than and greater than problems. Alright, so first of all, let me fix this. The way that we're going to graph them in Desmos is we're going to pretend that instead of in number 6 here, x over x minus 2 is greater than or equal to 0. But we're going to graph, actually let me do number 1. That 0 kind of throws things off. I'll go back to that one later. Let's do one that has, this is the worksheet here, rather large font. Let's start with number 1. Okay, so number 1 says that we have x over x minus 4 is less than or equal to 2. So you can graph these in Desmos.com or on your graphing calculator, but you can't graph them exactly like they are. It's just too complex. So I'm going to graph the left side first, which would be x over, and then on the bottom x minus 4. Oops, does that say? Where's my x? Here's my x minus 4. And what we get is this, it's called a hyperbola, and this is supposed to be less than or equal to 2. Alright, so we graph the right side and the left side separately on here. Okay, because if this is y, x over x minus 4, then that, x over x minus 4, is less than or equal to 2, is what this says. So we graphed it in 2 parts. And what we get over here is this hyperbola. It's in 2 parts. And you can see that the part that is shaded is the y is less than or equal to 2. So if I turn that off, this is just the y equals x over x minus 4. And then this shows you where it'll be true for this this problem over here. Let me zoom in just a little bit. Now you can see there's an asymptote here. We talked about that in earlier sections. And it looks like this asymptote is at 4. See, there's a vertical line at 4, that this hyperbola, as it increases on this side, it'll never reach the 4. And over here, as it decreases, it'll never reach x equals 4. So x equals 4 is an asymptote, which means it cannot be a solution. And you can see also that it could not be a solution because then your denominator would be 0. So I know that that's never going to be a solution. Also, the answer will never be, say, 5 here, because that's not part of the when that is less than or equal to 2, because at 5 it's above 2. The line 2 is this dark blue line right here. So it's only going to work when x is greater than or equal to 8. You can see that from the graph. Or over here when x is, let's see, well, it certainly has to be less than 4 because that's an asymptote. And is there any limit on this side? It doesn't look like it. So from the graph, it looks like my answer will be, this is from my graph. Okay, so from the graph, it looks like x has to be greater than or equal to 8, and x has to be less than 4. It cannot be equal to 4 because that's an asymptote. And to make greater than, I'm just going to underline that. Now, how are we going to do this algebraically? Here's how we're going to do it algebraically, just to kind of verify that our graph is the correct graph. You would say there's 2 cases. Either x minus 4 is greater than 0, the denominator, or x minus 4 is less than 0. Either one is true. We don't know yet which one it'll be. So for case 1, I'm going to do that x minus 4, the denominator, is greater than 0, so that it would be a positive denominator. If that's true, then I'll multiply both sides by x minus 4 to get it out of the denominator, and I would have x is less than or equal to 2 times x minus 4. And again, to make the less than sign say less than or equal to, I just underline it. And then I solve this little inequality, and I would have x is less than or equal to 2x minus 8. And then I would add 8 to, or let's see, no, then I would subtract 2x from both sides so that I get my x's together. So then I'd have x minus 2x would be minus 1x is less than or equal to negative 8. Now, when you solve this, oops, I don't want that part underlined. Let me just double check my steps here. So I multiplied both sides by x minus 4, and I got 2x minus 4, and the other side was just x. When I solve this problem, I have to divide both sides by negative 1 because I have a negative 1x. When you multiply or divide an inequality by a negative number, it switches the direction of your inequality. So now it's going to be x is greater than or equal to 8, which matches what we said on our graph, that x would be greater than or equal to 8. Now that's case 1. Now part of case 1 was also that it had to be x minus 4 had to be greater than 0. This part has to be true as well. Well, is that true if x is greater than or equal to 8? X minus 4 is greater than or equal to 0 means that x is greater than 4. If x is greater than 4, then x is greater than or equal to 8 doesn't have any contradiction there. X greater than or equal to 8 already takes care of the x is greater than 4. It has to be both of those things. So just the x greater than or equal to 8 part would satisfy both of those parts. But I do have to check that. So far for case 1, I've got x greater than or equal to 8. That's the solution that I have so far. But remember, there's another case, and the other case is if x minus 4 is less than 0. So case 2 is when x minus 4 is less than 0. And when it's less than 0, then I'd be multiplying both sides by a negative, and I would switch this inequality to a greater than. So this is the same right here. I would multiply both sides by x minus 4, except I would have to change that to a greater than sign. Let me finish this up, which means that x would be less than 4. So remember that this is the same thing, except this would be a greater than sign instead of a less than sign. And then we simplify this, and it'll look almost the same as the other one, except for the sign is pointing in the other direction. And we would subtract 2x from both sides to get negative x is greater than or equal to negative 8. And again, that we will have to divide by, this is the same as negative 1x, we'd have to divide both sides by negative 1 to get our answer. So that will switch the sign of the inequality to x is less than or equal to 8. Ooh. But remember, this is also true with the x has to be less than 4 part. It has to be both of those things. So where is it less than or equal to 8 and less than or equal to 4 is this part. A number less than 8, like 7, does not satisfy that x is also less than 4. So x is less than 4 is the part that we need for our solution. So we have two parts to our solution. Either x is less than 4, that's for case 2, or x is greater than or equal to 8. That's part of our solution. And that was a greater than or equal to 8. So our overall solution is those two parts together, and that matches the graph. And if you're using Desmos, you could take a screenshot of the graph and then paste it on here to show graphically what the solution would be. And then I want to look ahead to one where that's greater than or equal to 0. So that was number 6, I think. Yeah. So 6 is different because of the greater than or equal to 0 part. We have that, and 7 too. They both have the 0 and 8. So let's look at what happens with one of these. I'll do number 7. I think I did 8 earlier. Okay, so again, we have case 1 is going to be x plus 5 is greater than or equal, or greater than 0, so it's positive. And I'll do this one algebraically first, and then we'll look at the graph. And if that's true, that means that x is greater than negative 5, so we keep that in mind. And when I multiply both sides by x plus 5, I get 2x is less than or equal to, well, 0 times x plus 5 is still 0. So I just get 2x is less than or equal to 0. And if I solve that, divide both sides by 2, I get that x is less than or equal to 0. So look at what I've got here. I've got x is less than or equal to 0, and the part for case, the denominator being positive is also true, and x is greater than negative 5. So at what numbers are you greater than negative 5 and less than 0? We can write that combined so that x is between negative 5 and 0. It could be equal to 0, so I'll underline that one. That's case 1. Now for case 2, that's when the denominator is less than 0. X plus 5 is negative. So that means that x is less than negative 5. And in that case, you would multiply both sides by a negative number, so the inequality would switch the other way. But you would still be multiplying 0 by some number, so you would get 0. So now we have 2x is greater than 0. And we would solve that, and we would get x is greater than or equal to 0. But remember that the definition of case 2 was that that the denominator was also negative. So both of these parts have to be true. So what numbers do you have that are greater than 0 or equal to 0 and also less than negative 5? Is there any numbers that are less than negative 5, like negative 6, negative 7, negative 8, and also greater than 0? No. There's no solutions for case 2. It's not possible when the denominator is negative. So that means the only answer is the case 1 answer, and this happens on a couple of these problems, which is when x is between 0 and negative 5. Let's look at this on a graph. So our graph would be, we would put the left side, the 2x over x plus 5. That's one of our parts. And the other part is when y is less than or equal to 0. So I've got that y is 2x over x plus 5, and that is equal to 0. Now when we look at the graph here, let me zoom out. It is a hyperbola, but the second part of the hyperbola is never going to be less than 0. It's never going to be in that shaded region. So you can see that the only part to the solution is over here, and we can zoom in again to see that that will be between. Here's negative 5. There's an asymptote at negative 5. So it's never going to be equal to negative 5. But for all the numbers greater than negative 5 and less than 0, it will be in the shaded region below this hyperbola right in here. It can't be greater than 0 because then it's not in the shaded region anymore. So it's right here, and that matches our solution of x being between negative 5 and 0. Alright, I hope that helps you do a couple of these problems, and you should be able to kind of copy what I did in order to complete the rest. Now you don't have to do both graphs and algebraically, but I think it really does help you see what's going on to look at both of them. Thank you and have a great day.